Hi, in today's video I'm going to show you a custom homemade hydronic water heating system using wood heat as the heat source. And so I was just going to basically walk you through the different parts of it. And so we'll start with the wood stove. Obviously you have to have a wood stove, so that's what this is. And then on top of it, taking a hot water heater, they got a landfill and took a piece of 8-inch well casing, like WELL, like a water well. Apparently, I say that word funny, not like a blue well, but a water well casing, and I got that for free also. I hired a guy to weld it in the center of the tank. I can weld, but you got to have a airtight, watertight weld, and I'm not that good. So, anyways, the heat from the stove goes up through the water tank, which is basically how a propane hot water heater works. This is the bottom of an old propane hot water heater, in case you haven't torn one apart like I have. So basically, you've got a flame under here that's provided by propane, and it comes up the chimney, and that's how you get your water heated as it rises through here, and then obviously from the bottom of the tank as well. So that's the basic concept I copied here. So you've got the tank, and coming up here you've got an expansion tank, which basically I'm not totally sure why you have to have one. I kind of do, but I don't think it'd be 100% necessary, but it was recommended, so I have one. You have to have a pump to circulate your water, which is really important because if you don't circulate your water, it's going to overheat, and you can have issues that will be taken care of by another thing that I'll tell you about. So this is just a standard hydronic water pump that's designed to handle heat. One little unique thing I did here, because I do live off grid and I want to use as little power as possible, I hooked a dimmer switch to it, and so I can regulate how much power it's using. So I usually keep it just down to the bare minimum as far as taking power, but still circulating to my radiators, which I'll show you in a minute. So I've got hot water going out, the return line comes here, and then a couple of super important things you need to know if you're experimenting around with any of this is you have to have pressure relief valves. And so one is for temperature. If the water gets too hot, it'll go off and relieve the pressure within the tank. And the other one is for pressure, and I can't remember, I think it's like 5 pounds. It's not near as much as a normal hot water heater for hydronic. So you want to have relief valves, or you could definitely get hurt, have things blowing up. So I just have a temperature gauge here hooked up, so you can see I just started this a little bit ago. It's not very hot, but I usually, with this system, usually don't get up much over 140 degrees, which is enough, but you could increase it by putting coils inside the stove or different things, which I have experimented around with, and that is kind of the reason I like this is because it kind of just hovers around 140. You don't have to worry about it getting too hot as long as you're circulating it. So other than that, the pressure, I don't know a whole lot about it, but you don't want to have too much pressure. I'm not totally sure why, I just was told that. So anyways, once again, I'm not an expert, but this works. Haven't had any accidents, been using it for several years. It isn't our main heat source. I use it to supplement when things get really cold, like 5 degrees or colder. I'll turn this on and circulate some water into the house. I've been reluctant to commit totally to it because of being off grid and having to commit to it power wise. So that's the basic explanation. The last thing I'll show you real quick is a radiator inside the house, and that'll be it. Alright, so this is a radiator that I have in the house, and so the hot water is coming from out there, circulating in here, and it just puts off a nice heat. You definitely got to get the air out of these old radiators, but once it's full of warm water, it does radiate a pretty good amount of heat. And one of the nice things is, obviously, with these plants on here, it doesn't get screaming hot. So that's basically it. That's how it works. All right, well, I hope this video was helpful, or at least gave you some ideas. Like I mentioned, we live off grid, so the way we're uploading these is we drive 20-15 minutes to a location that has better internet. And when we got here, noticed a few things I wanted to clarify, and then I thought of 2 things I wanted to add. I wanted to add 2 safety things. Apparently there's a saying that old timers say, they say hot water will burn you, but steam will kill you. So you really want to be careful if you're experimenting with this to not produce steam. Make sure your water's moving, or you know what you're doing there. And the other thing is, a plumber told me that if you heat water up and then it sits for a while, there can be a lot of bacteria in there, and you can get what's called Legionnaire. And the reason I mention that is you might have the idea, well, how about instead of just heating, I can heat my household water and use it for shower water and stuff, which you can. You just want to pay attention to you're not using stagnant water that's been heated up. And then a couple things I want to clarify real quick that I noticed. One, you might have noticed that my temperature gauge was on the return side, which might seem a little bit odd, but originally I had my pump running the other direction, so the water goes through the tank and then hits that temperature gauge first. So that's how I know that it runs at 140 degrees typically over the years, just from experience. So right now it doesn't actually read accurately for that. But and then the other thing I mentioned in the video, that it runs at about, that one pop-off valve is at 5 psi or somewhere around there. That's not accurate. It's actually a 30 psi relief valve, which that relief valve is why I can sleep at night running this thing, because I know it's not going to blow the tank up and stuff. It's going to blow that thing first. But my system actually runs at about 10 to 12 psi, and that expansion tank is pretty critical in helping regulate that. So yeah, like I said, I hope it's helpful, and thank you, Isaiah, for taking the time to video this, and we'll see you next time.